Last week we focused on learning how to graph the parent function of all sine functions, y equals the sine of x, or y equals the sine of theta. So this week we're going to focus for a couple days on graphing cosine functions. So the parent function of all cosine functions is just simply y is equal to the cosine of theta, or y is equal to the cosine of x, where x is the measure of theta. So remember, when we're talking about graphing this cosine function, we want to use the radian measure for theta. So when we talk about theta, we're using our radian measure instead of our degree measure. So use radian measure for theta. And then we also want to recall that when we're talking about the cosine of theta, remember when we redefined what the cosine of the angle means? We redefined it so that we can understand that the cosine of the angle theta is the x value of that point of intersection between our unit circle and our terminal side of our angle. So we're just going to make a little note of that. So remember, the cosine of theta is the x value of the point of intersection of the unit circle and the terminal side of the angle. So we expanded our definition and understanding of cosine to include that definition. Just like the sine of theta is the y value of that point, the cosine of theta is the x value. So I already took the time to fill out my unit circle. I filled out all the radian measures and then all the x and y values of those points of intersection. And if you could just press pause on the video, fill out your unit circle real quick, and then press play when you're ready to continue, that'd be awesome. So eventually you're going to actually have to have the unit circle memorized. So me having you repeatedly fill out the unit circle is good for that process. So we're ready to go ahead and graph our function y is equal to the cosine of x, or the cosine of theta. And remember, the cosine of x is the x value of all of our points of intersection. So all of these x values are what we care about right now. And then we're plugging in all the radian measures of our angles. So let's fill in the rest of our x-axis here. So we have a full complete rotation from 0 to 2 pi. And from here to here we have 0 to pi. And we have 1, 2, 3, 4, 5, 6 spaces. So we can divide pi by 6. So if this is 0, this would be pi over 6. This would be 2 pi over 6. 2 over 6 reduces to 1/3, so pi over 3. This would be 3 pi over 6, which reduces to 1/2, or pi over 2. This would be 4 pi over 6, which will reduce to 2/3, so 2 pi over 3. This will be 5 pi over 6, which doesn't reduce, and then 6 over 6 reduces to 1 pi. Moving on. So if this is 6 over 6 pi, 6 pi over 6, I can talk. This would be 7 pi over 6. Then after 7 pi over 6, we would have 8 pi over 6, which reduces to 4/3, so 4 pi over 6. Then that was supposed to be a 3, huh? 4 pi over 3, sorry. Then this would be 9 pi over 6, which reduces to 3 over 2. Then this would be 10 pi over 6, which will reduce to 5 over 3, so 5 pi over 3. And then this will be, that was 10, so this would be 11 pi over 6. And then this would be 12 pi over 6, which reduces to 2, or 2 pi. So we've got our x-axis all labeled for us. And then when we plug in those radians, so when we plug in 0, well, the cosine of 0 is 1. So let's label our y-axis here. I'm going to count by halves. So this is 0.5. This would be 1, 2, negative 1, negative 2. So the cosine of 0 is 1. Then let's do the easy ones. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And then the cosine of 2 pi is 1. So now we just need to fill in the stuff that's in between that. And I'm going to grab my calculator to help me out so I can understand some of these values a little clearer. So pi over 6 is the same thing as root 3 over 2. So I'm going to plug in the square root of 3 and divide it by 2, and I get 0.866. So 0.866 is probably up here. Pi over 3 is 1/2, easy enough. 2 pi over 3 is negative 1/2. 5 pi over 6 is negative root 3 over 2, which would just be negative 0.8. So I see a curve emerging. It looks something like this. Then 7 pi over 6 is negative root 3 over 2. So again, it would be here about negative 0.866. And then 4 pi over 3 is negative 1/2. And there's our curve. 5 pi over 3 is 1/2. And then 11 pi over 6 is 0.866, or root 3 over 2. And there we go. So this is what a cosine curve looks like. And we have a periodic function, and this pattern that we see here is going to repeat over and over and over again, because if you rotate the circle once completely, you're reaching these coheights, and then if you rotate the circle again, you're going to repeat those same coheights over and over and over again. Moving on to our example, let's go ahead and do part A of example 1 together, and then you can do B through D on your own, and then check your answers with me. But we are going to estimate the values of the cosine of these angles based on the graph. So the first one we're given is to find the cosine of 2. So on our graph on the x-axis, we're clearly counting by pi and half pi's here. So we need to figure out where 2 is going to be. So I know that like the estimate of pi is 3.141, and then pi divided by 2 is 1.571. So we need to try to figure out where 2 is at in relation to these things. So let's see, 1, 2, 3, 4, 5. We have 5 steps in between. If I take 3.141 minus 1.571 and then divide that by 5. So we're counting by 0.314 at each step. So 1.571 plus 0.314. I'm silly. 1.571 plus 0.314 is 1.88. So 1.885. and then plus 0.314 again would be 2.199. So clearly 2 is going to be in between these two values. Let's see, probably about halfway-ish. So 2, it looks like the cosine of 2 is at this point, so we just need to find the y value of that point, which should be about here. And we have 1, 2, 3, 4, 5 steps, so we're counting by 0.2s. So this would be negative 0.2, negative 0.4, negative 0.6, negative 0.8, and negative 1. So it looks like we're kind of about halfway between negative 0.4 and negative 6. So I'm just going to estimate that this is at negative 0.5. And if I take the cosine of 2, I get negative 0.4. So we're pretty freaking close with our estimate on our graph here. So really, we probably should have been just a little bit higher than that. So 2 should have been a little closer here, probably. But again, it's an estimate. As long as we're within like 1/10 of the correct answer, we're fine. So why don't you go ahead and find the cosine of pi, 3, and 3 pi over 2 on your own. Press pause, and then press play when you're ready to check your work. So the cosine of pi, easy to find, negative 1. The cosine of 3 pi over 2, again, easy to find, 0. And the cosine of 3. So the cosine of 3 is going to be kind of close to 3.141. Counting by that 0.314, this would be 2.5. This would be 2.8. So 3 again is somewhere in between here, coming down to this value here, just above negative 1. Let's say that it's like negative 0.98, because we're really close to negative 1, but not quite there. And then if we want to check, the cosine of 3 is negative 0.98. Hey, nice. 0.99 if you round, but it's all good. All right, so we are done for the day.